Hi there folks, and welcome back to part 2 of this lecture. Here in part 2 we're going to be talking about the Earth in space and the annual march of the seasons, and this stuff is covered pretty nicely in pages 14 to 21 or thereabouts in your textbook. So let's start out, and this whole thing is really interesting because that simple statement here, our tilted orbit around the sun, explains pretty much everything you ever need to know about weather and climate. And that's something you've all seen and all learned, actually probably way back when in elementary school, that the Earth is orbiting around the sun tilted at an angle. So let's look at this again. Basic fact, pretty much all energy and life, therefore, that we have on Earth comes from the sun. And you can think of the sun perhaps here as a big light bulb. And the sun is blasting energy into space, and it does so more or less at a constant rate. It's not quite constant, but it's more or less constant. So if that's the case, if you're the Earth, the amount of energy you receive from the sun is a function of where you are in space as you orbit around the sun, and more importantly, actually, how you're oriented towards the sun. So location of and orientation of the Earth relative to the sun controls, if you will, how much energy we receive. And that's very much analogous of a light bulb, let's say, hanging in your dorm room, right? That light bulb sends light into your room at a constant rate. And depending on where you are in your room and depending on how you tilt your book, that will depend on how much light you get on your book, right? And the same applies to the Earth. Depending on where the Earth is in space and how the Earth is oriented towards the sun, that controls how much solar energy will arrive at the Earth's surface. The basic movement is pretty clear, right? Here we got the sun in the center, the Earth is orbiting around it. It takes about a year, 365 days, for one complete revolution around the sun. The orbit itself is slightly elliptical. It's almost a circle, but a little bit elliptical. And our rotation axis, the connection between the North Pole and the South Pole, is tilted by about 23.5 degrees relative to our orbit. And that tilt is really what controls weather, controls climate, gives you snowstorms, gives you hailstorms, gives you tornadoes, gives you hurricanes and all that stuff. So that tilt, that basic figure that you see here, that you've seen before, is really where the whole story starts, and it really explains everything we need to know. Let's go on. Very important to emphasize, right? Here's that globe. You can find that globe on the quad there. Yeah, here's the guys putting it up. And when you walk by that globe, next time you go over to the library, stand there, have a look at it, and sort of appreciate the tilt of the rotation axis that you can see. Because the Earth is not straight there, and the Earth is correctly depicted tilted at an angle. And that simple fact that the Earth is tilted at an angle, orbiting around the sun, really explains everything about weather and climate that we possibly need to know. Okay, let's continue on. Orbit around the sun plus tilt gives you seasons. Well, that's a repeat, right? I just want to really emphasize this. We have our orbit, the fact that the Earth was orbiting around the sun, and we are tilted as we are orbiting, and that gives us seasons. The sequence we know from summer to fall to winter and then back into spring. This is the time of the year depicted here where we have summer in the northern hemisphere and winter in the southern hemisphere. So everything north of the equator, North America for example, we have summer, that would be June, July, August. In the southern hemisphere at the same time, think Australia, there's winter. So if you want to go skiing in June, the best place to go is to Australia and New Zealand. The inverse happens when the tilt of the axis is as such. Northern hemisphere is tilted now away from the sun, and the northern hemisphere has winter. In contrast, the southern hemisphere is pointing towards the sun, and there's summer in the southern hemisphere. So the best time of the year to go to Australia and New Zealand, unless you want to go ski, is December and January. And then we have the fall, and then we have the spring, where the tilt still exists. The Earth axis is still tilted. We call that the polarity of the Earth axis. The tilt of the Earth axis remains the same all the time. However, in the spring and in the fall, if you will, the tilt is sideways in the sense that neither of the hemispheres is pointing towards or away from the sun. So, what we call summer here in Massachusetts is the time of the year where the Earth, in its orbit around the sun, is pointing the northern hemisphere towards the sun because of the tilt of the axis. What we call winter here in New England is when the northern hemisphere is tilting away from the sun because of the constant tilt or the polarity of the Earth axis. This is this critical concept that you should really make an effort to understand and comprehend. So if this is unclear on this diagram, make sure you look it up in your textbook and maybe you Google it as well. Because now we can figure out the annual march of the seasons. And again, the big picture idea remains the same. Our tilted orbit around the sun explains everything, right? So going from summer to fall to winter to spring, that transition that we're so used to here in the mid-latitudes is caused by the tilted orbit of the spherical Earth around the sun. Here's that little flow chart that I have for you, and I'm going to explain this in part 3. But effectively, you can start at the top. We got the seasons here, and they are determined by the amount of sunlight. That makes sense. That results in seasonal temperature variations. So depending on how much sunlight we get, it's either warmer or colder. So when it's warmer, as in the summer, we get more sunlight. When it's colder, as in winter, we get less sunlight. And then we'll talk about the stuff here below in part 3. Here's the situation as we already seen it. Northern hemisphere summer, southern hemisphere winter. Northern hemisphere winter, southern hemisphere summer, and then the fall and the spring. Note the tilt remains constant all year around. Seasons are reversed between the northern hemisphere and the southern hemisphere. That's a cool thing, right? So if you're sick and tired of hot, steamy days in July and August and you just want to go skiing, all you got to do is fly to the southern hemisphere. You can go to Chile, you can go to New Zealand, and there'll be snow because they have winter. And if it's January and it's cold here in North America and you just want to get out and you just want to have summer, all you got to do is fly to the southern hemisphere. For example, to South Africa, to Madagascar, because it's the southern hemisphere and they have summer. So here's an animation. Right? There's plenty of these animations, and this animation is actually accessible through your textbook. Let's start in June. Right? June, July, August. That's what we call northern hemisphere summer. You can see that the tilt of the axis is as such that the northern hemisphere is tilted towards the sun. Southern hemisphere is tilted away from the sun. There's more sunlight in the northern hemisphere. We have summer. There's less sunlight in the southern hemisphere. They have winter. Now watch as that tilt remains constant as the Earth orbits now from June into September. That's what we refer to as the polarity of the Earth axis. So now you find yourself in the fall, September, October. Your tilt hasn't changed, except because of that tilt remaining constant, we are in a situation where the tilt is kind of sideways, if you will. Neither hemisphere is tilted towards or away from the sun. Let's look at the Earth in profile. Right? The tilt of the Earth axis is into the screen or out of the screen. There's no tilt relative to the sun. Both hemispheres are equally exposed to sunlight, 12-hour daylight, 12-hour nighttime. Let's hide that profile. Let's fly into the winter. Note that the tilt doesn't change. That's what we call polarity. And now we find ourselves in December, January, right? What we call northern hemisphere winter. Note that northern hemisphere is tilted away from the sun. Southern hemisphere is tilted towards the sun. They get more sunlight. They have summer. We get less sunlight. We have winter. Let's look at this in a profile. Right? Imagine the light of the sun coming from the left. Here's our Earth axis. It's tilted by about 23.5 degrees. Northern hemisphere is tilted away from the sun. So there's only a relatively small part that's illuminated by the sun. That's why it's cold. We have winter. Southern hemisphere is tilted towards the sun. Larger part of the southern hemisphere is illuminated by sunlight. They have summer. Note that the Earth is rotating, of course, around its rotation axis once every 24 hours. And now let's fly into the spring. And we get into one of those sideways tilt situations again. The tilt has remained the same. The Earth axis is still pointing to the same spot in the universe, which happens to be the North Star. But there's no tilt away or towards the sun. That's what we call the March equinox. We call that spring. So now you know everything you need to know about why we have seasons and climate zones. Let's put this together in a diagram. Here we go. Here's the sun in the center. The Earth is orbiting around the sun. Okay? And of course the Earth is also rotating at the same time around its rotation axis. Let's take the situation in June. Northern hemisphere summer. Northern hemisphere is tilted towards the sun. Therefore the days are longer than the nights. And we know that, right? During the summer we have nice 13, 14, 15 hour long days and short nights. The sun is also very high in the sky. We'll talk about that a little bit more. Therefore, the northern hemisphere receives more energy from the sun and it's warmer. We have summer. Now flip that into the winter. Let's say December, January. Now the northern hemisphere is tilted away from the sun. We have short days and long nights. We all know that. That's exactly what we're having right now. The sun remains fairly low in the sky. We receive not a heck of a lot of energy from the sun, and therefore it's colder, and we have winter. And then, of course, we have the spring, and we have the fall, which are exactly the same. Neither hemisphere is tilted towards the sun. Day and night are about equal in length. The sun is lower than in the summer, but higher than in the winter. There's less energy than in the summer, but more than in the winter. Therefore, it's colder than in the summer, but warmer than in the winter. So there you have it. Northern hemisphere summer, fall, northern hemisphere winter, spring. And then, of course, you could do the same thing for the southern hemisphere. You would just have to flip summer and winter because they occur inverse. So this was the March of the Seasons and the Earth in Space, right? Very crucial concepts. We will review them now in part 3, and we'll also review them next time in class. But it's a difficult thing sometimes to think about how the Earth orbits around the sun in this three-dimensional space. So somehow review the animation again, look for animations online, see if you can wrap your head around how that works. And I'll see you back in part 3.